Hello, everyone. Thank you for deciding to come to this talk. I really appreciate it. There are a lot of really cool topics going on right now, so I really appreciate you coming to this one. Just a short, quick question before we start. Do we have anyone here who's like a security expert, works with pen testing, Red Bull teaming, stuff like that? Hands up. Cool. I really appreciate you both. Thanks for coming, and I really hope that this will be useful for you too. But it's mainly addressed towards like web developers, like people who do security but not in full time. Okay, let's get into it. So let's talk about cross-site scripting. This is me. This is my name, Benedek Gagyi, and this is also my Twitter handle. I posted the slides there, so if you prefer to follow along on your phone, you can do that. So, what's up with security? I mean, if your only source of information about cybersecurity is movies, then you might have a really strange idea about like what's going on in this space. Usually, Hollywood movies portray this kind of job in two ways. They are either portraying a hacker, for example, like in the movie Hackers, where Angelina Jolie is this really badass character who can crack any site. She's like really cool. Or there's the other kind of movies where they portray people trying to stop the hackers, and these people will do anything to make that happen. For example, in Die Hard 4, Bruce Willis actually rams a police car into a helicopter just to stop the hackers. Or even better, in the latest Fast and Furious movie, the good guys attack a frigging submarine with cars just to stop the hackers. Yeah, it's not too realistic, and it also kind of makes me feel uneasy. But if we come back to the real world, I still feel kind of uneasy, because if I read a blog post about security or like a book or listen to a talk, sometimes I feel that they address like security experts. And there's nothing wrong with that. Like, security experts need to get their information from somewhere. But for me, who's like a regular web developer who has to juggle like performance, accessibility, CSS, the latest JavaScript frameworks, testing, and all these things, sometimes it's really hard to like get into that vibe. Like, it'd be really cool if I was just as good as Angelina Jolie and I could like skate around the city effortlessly and then go home and crack the FBI, or be as brave as Bruce Willis and stop a DOS attack by jumping out of a building. That would be really cool, but that's not going to happen realistically. To go with the movie analogy, I'm more like the guy sitting in the 7th row, like eating the popcorn, trying to enjoy the movie, paying attention not to fall off the stairs when going home. So yeah, I'm closer to that. But that kind of made me realize that we have these two categories usually, like black hat, white hat, red team, blue team, attacker, defender. But we kind of need a third one. So let me introduce you to just enjoy the show and try to learn from it hat. Yeah, it doesn't really make sense. It's basically just a joke. But bear with me here. I really believe that you should try to enjoy the show. And you don't have to be an expert to be able to enjoy something. If you just take the knowledge you already have, add a little bit extra to it, then in my experience and in my opinion, you can reach a level where you can already start to enjoy learning about. You can already appreciate the beauty of it. And that makes it much easier to keep progressing. To give you an example, I drink a lot of tea. I'm basically an addict. But when I first heard about the most prestigious, most esteemed kind of tea called pu'er, I was like, what is this? Is this like a bird's nest or something? But then I started digging into it, started reading about it, used a bit of my wine tasting knowledge, and I managed to get to a level where I started enjoying it, so I started drinking more and more, and then I got to a level where I'm actually able to like appreciate the fine details of this kind of tea. And the goal of this talk is to show you XXSS attacks. That's the most important goal. But as a secondary goal, I like to show you the beauty behind these things, the creativity that lays behind all these kinds of attacks. Because for me, that was crucial to start enjoying it, and actually it still empowers me to learn more and more about these kinds of things. Okay, let's get into it. So we can't really talk about XSS without mentioning Semi. Semi is the person who executed the first XSS attack in 2005. So what he did was he added a bit of malicious script onto his MySpace profile. Yeah, 2005, still MySpace. And what this malicious code did was, if you visited his profile and you also had a MySpace profile, first of all, you added an extra sentence to your biography saying that, but most of all, Semi is my hero. And the second thing it did was it copied itself, so the script copied itself, and was copied into the visitor's profile. So basically, it started to spread. And in only 20 hours, 1 million profiles were actually affected. And again, it's 2005. People weren't walking around with internet in their pockets. So I think this is pretty incredible. Do you know who didn't think so? The FBI. Sadly, Semi was actually had to plead guilty of hacking, whatever that means in this context. And he had to pay a fine and do community work, but what's worst of all, he wasn't allowed to go on the internet for 3 years. But don't worry about him, he's fine already. He's like a super successful security researcher, so if you're interested in these topics, just check him out. So the flow of his attack looked like this. He created a malicious script and managed to inject it into his own profile. What this means is he basically put it into a user input, and then it got saved on the server. So when somebody else loaded Semi's profile, they downloaded the profile, and with it came the malicious script too, and it executed on their machine. So this is what happened, and this is like the most basic kind of XSS attack. So thank you for coming to my talk. See you all at the after party. Obviously, I'm kidding. This is only where the rabbit hole starts, and I can't wait to get deeper in there. But I'd like to stop here for a second. If you know this much, that's already great. It's going to, knowing that, hey, I have to pay attention for user inputs, and somebody might add a malicious code that somebody else might see, knowing this is already really cool and really useful. Many teams I saw weren't even aware of this one, so great. OK, let's continue. So like I said, there are many kind of attacks, and I'm going to try to show you a few. But when we have so many different things, it's good to somehow categorize them. And there are many ways to do this. There's no like one official way. I like this one the most, which has like 2 axes. So the one I just showed you, Semi's attack, is a stored server-rendered attack. But what about the other kinds? Let's see. Another kind of XSS attacks is reflected XSS. In this case, imagine that you have a URL where you have a query parameter where you can enter, for example, a name. And then the site will take that parameter and just put it into the site itself. For example, imagine a greeting, like there's here name equals Ben, and when the site loads, it will render hello Ben. That's simple. But what happens if I put something malicious there instead of the name? Well, if there's no sanitization, it might be just as well taken and put into the site. It gets executed, bad things will happen. So in this case, the attack flow is a bit different. So the attacker isn't saving the malicious code on the server. Instead, they create a URL containing this malicious code. They send the URL to the victim via Facebook Messenger or any kind of message. And when the victim clicks on it, they make a request using this URL. And either on the server or on the client side, at some point, some code takes that value of the parameter and puts it into the site. So when it arrives here, it will be executed, and again, bad things happen. So one of the 2 categories is reflected and stored, but we are still missing one. And to be able to understand what we're missing, we have to take a step back and ask ourselves, OK, what actually happens when like an XSS attack goes on? Well, we have a harmless string, and at some point, it gets transformed into a harmful script. So from regular string, it becomes a script that can actually run. So basically, from this, we get this. That's the main idea. If that's the only thing you remember, that's already cool. And where this transformation can happen basically at two places. On the server, if you have a server-rendered site or some kind of templating system, or in the browser, in the client's browser. Some regular JavaScript code just does some kind of transformation and sets an inner HTML with a string, and bam, something that was a string became a script. So that's why we have server-rendered and browser-rendered categories. And you see, that's why I really like this two-dimensional thing. These things can be combined. So we can have stored attacks that are browser-rendered, and we can have reflected attacks that are server-rendered, and so on. But like I said, this is just one way of putting it. There are many others. Also, one more thing about XSS, and I think pretty much security in general, the namings are usually not so good, not so fitting. Sometimes they are really confusing. In this case, for example, server-rendered and browser-rendered are just what I like to use because it makes more sense to me. But if you read like a blog post or a book, you'll most likely see DOM-based and non-DOM-based. Not DOM-based meaning that you make the transformation into DOM. Yeah, for me it makes a lot more sense saying server-rendered and browser-rendered. So until now, you learned that user inputs are bad. Like, you have to take care of them. You have to sanitize them. The question is, where? What's the point when I can say that if I sanitize the user input here, I'll be fine? Well, one place could be before the malicious actor sends them on their client. But we know how client-side checking is. It's pretty easy to circumvent. You just create a request with a curl or postman, and that's it. So that's not going to work. So we can choose either the server or client-side on the receiving end. So the problem is, and you might have noticed this if you developed anything for browsers, that the browsers are sometimes super weird. Sometimes by looking at the HTML, you can't say for sure what will be rendered. Here's an example for you. This is invalid HTML, but as we know, the browser tries to help and will render invalid HTML somehow. So do you have an idea what will be rendered if we do this? I give you a second just to maybe think about it. So it will render a div tag, inside it a script tag with the title being the closing div tag, and then because the browser is really friendly, it adds the closing script tag and the closing div tag too. Okay, fine, it's strange, but it's nothing super scary or anything about it. Let's see what happens if we switch the two. So here we had a div tag and inside it a script tag, but now we have a script tag on the outside and the div inside. But the structure is the same. So we'd expect that it would render something similar. Like I said, browsers are weird. It renders something completely different. It will render a script tag, inside it a div tag, but the title doesn't contain anything, and the closing script tag is actually like a real tag, and then it adds just a random quotation mark at the end. So why does this happen? Why is there a difference? Well, it's because the browser, when it looks on it sees a tag, then it sets some kind of expectation. So when it sees a div tag, it expects to contain HTML. So it will try to parse its content as HTML. But when it sees a script tag, it will take basically everything until the closing tag and try to parse it as JavaScript. So that's why there's a difference between these two. OK, but you might say, this is an interesting quirk, but is that dangerous, actually? Well, yeah, it is, because it means that we can't, on the server, we are not able to precisely predict what the browser will render. Without the browser, we can't tell what is going to come out of a string. So because of this, we can't really do sanitization or high-quality sanitization on the server. So we have to do it on the client side. And all those attacks that use this kind of situation when we have a string, the browser takes it, changes it a bit, mutates it, and then spits out something dangerous, we call these mutation XSS or mXSS for short. So how would you how would this happen? Imagine you have a div, you create it with JavaScript, and then set its inner HTML with a questionable string. You don't know if it's harmful or not, but you set it there anyways. So in this case, this is an image that has an invalid source and has an on-error value, an on-error attribute. In this case, the browser tries to download the image. It will fail, so everything that's in the on-error attribute will be executed. And that's how, if there's something malicious inside there, that gets executed. So if we set this string to the inner HTML, what happens? The browser first parses it and then interprets it, which basically means that before we could do anything with this, it's already executed. So clearly, this is already too late. So we need a tag. We need a kind of tag that has a mechanism for holding HTML that is not to be rendered immediately. Instead, maybe instantiated subsequently. This is a quote from the documentation, so we do have a tag like that, and it's called the template tag. Has anybody here ever used the template tag? Okay, not surprised. For me, the first time I heard about it was in this context. So it's not something that you meet too often. So yeah, like the documentation says, the template tag is really cool because it has the same API as a div tag. You can create it via JavaScript. You can set its inner HTML with anything because it won't be interpreted. If there's something malicious there, it won't run yet. So you can clean it before doing anything else with it. You can use the DOM functions to do that. For example, in case of images, you can remove all the nasty attributes that you don't want there. You can use like a blacklist or whitelist, doesn't really matter. You can clean it. And once you're sure that it's clean and it's not harmful, you can set the value of inner HTML of a div with the inner HTML of the template. And that's it. Now you're safe. No mXSS attack will ever succeed, right? No, of course, it's a bit more complicated than that. So a few months ago, I don't know if you saw this, but a Japanese XXSS researcher found a vulnerability on the Google search page, so basically the most visited web page on the internet. And it was a pretty big thing, a pretty big deal. And I think the attack itself is really original and really nice. So I'll try to explain shortly how this happened. So all the code that you need to understand what's going on here is this much. We have a NoScript tag, inside it a p tag with a title that contains the closing NoScript tag, a malicious image, and then the whole thing is closed. Seems familiar, right? It's like some kind of invalid HTML. We can already expect that the browser will do something strange with it. So we take the tools that we already learned about, the templates, and render it inside a template. And we'll have an opening NoScript tag, inside it I just surprised myself with a button. Cool. So inside it, we have some random string, but it's just a title, so it doesn't matter what's inside there, and then some closing tags. But when we so that's not harmful. But when we take the inner HTML of the template and give it to a div, it will render something completely different. It will render a NoScript tag, inside it again a p tag, but then the NoScript tag is closed, and we have a malicious image, not in a string. So the on-error thing will be executed, bam, we're hacked. And then some random closing tags. So why does this happen? Somebody lied to us, because there was a difference between the template and a div. And for me, when I started looking into this, I was like, it's probably the NoScript tag, because that's, again, something that you don't really use too often. So I started reading the documentation. And on the third or the fourth run, I realized that the answer was in the first row. It says that the NoScript tag represents nothing if scripting is enabled, and represents its children if scripting is disabled. So the thing is that in template tags, scripting is disabled, and in div tags, scripting is enabled. So that's where the difference comes from. And I'd like to stop for a second to appreciate, again, the ingenious nature of this attack. Like, how creative you must be to take a really not well-known element like the NoScript tag and realize that, hey, there's like this really strange quirk there, and then combine these not scary things into a full-blown attack. Basically, if we're talking about XSS, it can't be bigger than having a Google page vulnerable for that. So I think this is pretty nice, and this is what I consider like beautiful. OK, but up until now, we were always injecting JavaScript. And if you manage to put JavaScript into somebody's site, yeah, you can do a lot of nasty things with it. But the thing is that you don't actually need JavaScript to be nasty. You can, if you can't inject JavaScript, the users are still not, you can't inject JavaScript, then the users are not safe yet. And so we're going to talk about scriptless attacks from now on. But to be able to do that, we have to take a step back and ask again, what is XSS? Well, it's an acronym. It stands for cross-site scripting. But I just said that you don't need scripting to execute an XSS attack. So what gives? Again, it's like a confusing naming. But every time I see XSS, I don't think about cross-site scripting. I think about cross-site something. Some kind of thing is executed, and that's how malicious things happen. OK, naming out of the way, let's get into CSS injection. So imagine that we have a site where somehow I'm able to inject one single CSS attribute, just one. So I'm inserting this, a background image with a URL that points to an evil site that's owned by me. OK, so there will be a strange background image. Who cares? Well, the thing is that when the browser tries to load an image, it has to make a request to the server that's specified here. And with that request, a lot of really interesting information travels too, namely headers. And inside the headers, we can already find out the IP address, the operating system, the browser, stuff like that. OK, this is by itself not enough for an attack. But imagine that you're a hacker, and you're trying to figure out what's the easiest way to hack a site. And if you manage to do this, you can gather information about the users of that site. And if, for example, I figure out that they are using some kind of older browser that has widely disclosed security issues, I have an angle. So giving information to somebody who wants to hack you is far from ideal. And like I said, by itself, this is not dangerous, but it could be a really important stepping stone for something a lot more scary. If you manage to inject an actual selector too, things get worse. Because if you have selectors, you have pseudo-selectors. And you have pseudo-selectors, you can check if something has happened or not on the site. For example, you can use the checked pseudo-selector, and this way you can figure out if the user has turned on, for example, the two-factor authentication. Again, if I find out that a site's users don't really use two-factor authentication, I know how to attack them. It's really valuable information. Or another thing you could do is check the links, if what the users visited. For example, if there's a really important security documentation and nobody reads it, then I can presume that they are not following it. And again, that's useful information for me as an attacker. So basically, I can do user behavior tracking. But it gets worse if we add attribute selectors. In this case, I can basically steal the value of some inputs. OK, not just like a text input, but if there's like a drop-down box with predefined values, then I can write a selector from each one of those. So if you have 5 values, I'll have 5 different selectors. One of them will fire because one of them will match the selected value. I'll get a request into my site with this. And because I just added some kind of parameter, I can figure out where the super secret meeting is going to happen. And it gets even scarier. So in React, if you have an input element, React by default will add an attribute to it called value. And even if this is a password input, it will still have a plain text attribute on it called value. And because this is an attribute, I can already write attribute selectors for this. So basically, it's possible to write a keylogger using only CSS. It's a super complicated thing. As an attacker, you have to have many things going on for you to pull this off, but it's possible. And again, let's stop for a second and appreciate this. Somebody took the time and wrote a keylogger using only CSS. The creativity boggles my mind. It's so cool. So yeah, the point here is that you can do data scraping and keylogging when you can inject some kind of CSS into the page. So yeah, you don't need JavaScript for that. CSS is also scary. So I still have like 40 minutes from my talk, but I really appreciate you coming, so I want to give you a gift. You thought that you're only going to learn about XXSS, but here's my gift. You're also going to learn about on-site request forgery. Yeah, OSRF for sure. This is a kind of attack that's usually used in combination with XXS, and that's why I'd like to show it to you. So if you have like a regular website, it basically has two things: the HTML, the site itself, and alongside it, the cookies that were saved or set before. So if a malicious actor comes and somehow manages to inject into the site one single link, nothing else, just a link, an anchor tag, then some pretty interesting things can happen. You see, if the user clicks on this link, a request will be sent to the server of this site. So if this is a bank, the request is sent to the bank's site. And with that request, the cookies are also traveling. And among the cookies, there's usually some kind of identification, a session ID or something like that. So if this malicious link is something like this, API make admin and the user, what happens here is that the malicious actor basically took an envelope, closed it, gave it to a user, and told them, hey, take this to your bank, give it to the teller, and say that do whatever it says inside that envelope, and then leave. Basically, you let somebody else define what the bank should do with your privileges in your name. So to simplify the whole thing, if you're an admin and you click on that link, because you're an admin, you can make somebody else an admin, and then hell breaks loose. So how can this be used? Yeah, with HTML injection. So you couldn't inject CSS, you couldn't inject JavaScript, no problem. If you can inject HTML, you can still inject the link that points to a target that's like, for example, there's an API endpoint, send money. It takes two parameters, how much and to who. And if I set how much, a huge number, and to who, my own account, like the attacker's account, if somebody else clicks on it, the money will be sent from their account to the attacker's account. So that's kind of scary. But what if I can't inject a link? No problem. I can still do the same thing using a form. So basically, a form with a button is just the same thing as a link, with an added benefit that you can say that it should be a post or a GET request. Again, you have an action, send money, blah, 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 and then you have the button, and if the victim clicks on this button, the same request will be sent. OK, that's cool, but it gets even worse. You see, if for some reason this OSRF thing doesn't work out, you can still check the code of the site. So not the code that you as an attacker wrote, the code of the site itself. And sometimes you find things there that could betray the site and basically like put a knife in their backs. Imagine a situation where the site already contains a script like this. It takes a button or some element from the page and then takes the attribute of that element and sets it somewhere else, for example, for the HTML part. Basically, it takes something, a value, a string, and then makes HTML out of it. That's how XSS attacks are born, usually. So if I manage to inject one single line of HTML like this, which has the correct class on it and has a value, an attribute that is malicious, in this case it's encoded with less than and greater than things, but it will become like a script alert like the earlier examples. So in this case, if the code that already exists on the page runs, and combined with the HTML I managed to inject, again, an attack was made. And the thing is that we use so much code that we don't control third-party stuff. And I'll just give you 2 examples. So if there's a site that uses Knockout.js, any site, if it uses Knockout.js, and you manage to inject this one line of code, anything that's inside the value there will be executed. And that's all you need. You figure out it uses Knockout.js, and then inject this one line. Or the same with Bootstrap. The syntax is a bit different, but the idea is the same. You figure out that they use a third-party library that has a known vulnerability, and then you don't even have to think. You just have to figure out a way to inject one line of HTML. So what I'm trying to get here is that there are so many ways to get attacked even if somebody can't inject JavaScript into your page, because there are other things they can do. And out of all of these, I think for me, the most scariest are images. Because we have so many places on the internet where you can upload an image, profile picture, stuff like that. It's a pretty common use case. But at the point where you let a user define the source of an image, bad things could happen. So let's go back here, the OSERF thing, or the malicious image thing. If they are able to set an invalid source and also set an attribute that contains an honor attribute that contains something malicious, that will be executed, bam. But usually sites don't let you add extra attributes. They just let you define the source and nothing else. Well, there are techniques to escape that, so to basically close the source parentheses and then add anything else, but those are well known and kind of easy to avoid. Let's say that you can only put something in the source. It's still dangerous. You remember OSERF? If you manage to add an image that contains a URL to an endpoint that's dangerous somehow, the user doesn't even have to click on any link or something. At the point when the browser hits this image, the request is made. They won't even realize. They might just see like a small error in the console that, OK, the response wasn't an image, and that's it, and their money was already wired. Yeah, but OK, OSERF attacks and CSERF attacks are not that hard to defend from. And you could also set like a CSP. Do you know what CSP rules are, content security policy? Yeah, so really short, it's a way to tell the site that, hey, if there's a request made from this site to another one, don't allow it. So you can basically make a whitelist that these and these and these sites can be called, no other ones are allowed. So that means that you can't just make a call to your own evil site that you control, because it won't happen. But if you have a CSP rule, it means you have to open doors to calls that you as a developer want to make. For example, you might use Facebook tracking for your site to know more about your own users. And that means that your site, by design, is going to make requests to the Facebook servers. No problem, you just add an exception. OK, Facebook is allowed. But if Facebook is allowed, I, as an attacker, can use that and also add Facebook tracking to your site. But so it's tracking, it's not a regular image, but with my ID. So basically, from then on, if any user does anything on your site, you get a Facebook event, but I get a Facebook event too. And we're back at the situation where if I manage to gather information about your users, I have a lot better chance to basically hacking them. So yeah, handling images is pretty hard. But up until now, we were always like using really typical user inputs, like what Semi used was the bio field with images is like a profile picture. Yeah, these are straightforward. But if we take a step back, we can think about, OK, what do we consider a user input? For example, are cookies a user input? I think so. For example, there are many sites where you have cookie-based output. For example, a good example is sites where you have search history. So you start typing, and like your search history appears. For performance reasons, it's really cool to store that in a cookie, not in a database, so you don't have to make a request with every single letter type. As a developer, you're like, whoa, I'm really cool. I made a really performant site, really good UX. The problem is that you're basically taking the value of the cookie and displaying it. And because you might think that, okay, but nobody, cookie is not a user input, they can't touch it, you might not sanitize it. And if a cookie-based output is paired with a subdomain takeover, so if you have a site, for example, www.example.com, and I manage to take over like malicious.example.com, then I can set cookies that are site-wide, that are valid for example.com and all of its subdomains. And people use these cookies on purpose usually, because if you want to transmit information between these subdomains, local storage won't work because that's subdomain specific, so you have to use generic cookies. And if you do a subdomain takeover, you can set these as an attacker, and again, bad things happen. Or another example of questionable user input. Do you consider your headers user input? When you're browsing the web, the browser sets them. You don't really have control of them as like a regular user. But as an attacker, I can set my user region to something malicious, or the client IP against something malicious. Why would that be useful? Well, imagine that there's a company and they have an internal application. It's internal, so it can be viewed only from the internal IP, where they list all the user IPs to figure out where the users come from. Well, since it's an internal application and no user can see it, they don't secure it. They're like, oh, okay, we don't care. They just throw it together in a few days. And because they think it can be attacked from the outside, there's no sanitization, so anything sent in as a user agent is displayed without sanitization, and bam, an internal app was affected by an XXSS attack. And that's why they call this blind XXSS, because you're sending something in, you don't see what's going to happen with it, but at some point you might get like a response back that, hey, this script was run somewhere. And what I'd like you to take away from this is that non-user facing doesn't mean it's not attackable. Basically, everything's attackable, and if you're using data from the outside, that data might contain something malicious. So you have to really pay attention to that. Like I said, I wanted to show you ways how XSS attacks can be done, and this was the main focus of this talk. But okay, come on, we can't really do a security talk without at least mentioning a few ways to mitigate or stop these attacks. So yeah, that's I'll do, but in a really short TLDR way. So first of all, you have to validate and sanitize the input. Please do that. You have to beware of images. So if you really need to make some kind of image upload, what I would do is just upload the image as a binary and host it yourself. Anything that's hosted somewhere else is dangerous in some way. Don't try to be smart. Don't write your own crypto. Don't write your own sanitizer. These things are super complicated. So do you remember the Google vulnerability I told you earlier about? The vulnerability itself was part of an open source library basically half of the internet uses. And a lot of really smart people are paying attention to it. And this vulnerability was there for 3 months. So yeah, if all these people couldn't figure out for 3 months that there's a vulnerability there, I'm pretty sure that if you write your own thing, it will have more vulnerabilities. So yeah, don't try to be smart here. Use the framework. The front-end frameworks nowadays are super friendly. They will sanitize all the input. Angular, React, Vue, they all do this. It's nice. And if you're trying to do something dangerous, they will let you know. I really love, for example, React named their way to input unsanitized input dangerously set inner HTML. Basically, the name itself tells you that, hey, you're doing something dangerous. Pay attention. So that's good. But also pay attention because frameworks have their own vulnerabilities. So by using a framework, you might introduce something that you don't know. But it's still much better than writing your own stuff. One thing you should do is just update all the third-party components regularly. Use some kind of security checker like npm audit or snake or something like that. So yeah, we can't really write a web page nowadays without third-party dependencies. That's just a norm. What you can do is at least try to pay attention that what you're shipping to your users is code that's as secure as possible, even if you haven't written it. So yeah, please try to stay safe. It's not trivial. It takes a lot of work, but your users will thank you. But also, please don't forget to have fun. There's so much beauty and so much creativity in all these topics, and you can learn so much about the web and the browsers by paying attention to these small details. So thank you very much for coming. I'll be here if you have any questions, and see you all at the after party and tomorrow. Thank you.